Okay, so as in the last video, we did electronic configuration of next 10 elements from 11th element to the 20th element, means from sodium to the calcium. Alright, we started discussing about the electronic configuration of sodium, and the electronic configuration of sodium is 1s2, 2s2, 2p6, 3s2. Then magnesium 1s2, 2s2, 2p6, 3s2. Aluminium 1s2, 2s2, 2p6, 3s2 and 3p1, right? Then we have silicon 1s2, 2s2, 2p6, 3s2, 3p2. Then we have phosphorus and 1s2, 2s2, 2p6, 3s2, 3p6, 3. Alright. Then we have sulfur 1s2, 2s2, 2p6, 3s2, 3p4. Then we have chlorine 1s2, 2s2, 2p6, 3s2, 3p5. Then we have argon 1s2, 2s2, 2p6, 3s2, 3p6. Then potassium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Last but not the least, calcium 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Alright, in today's video we're gonna discuss the electronic configuration of next 10 elements from scandium to the zinc. Alright, Sc is symbol which is the representation for scandium. Then Ti is for titanium, V is for vanadium, Cr is for chromium, Mn is for manganese, Fe is for iron, Co for cobalt, Ni for nickel, Cu for copper, and Zn for zinc. Which means today we will be driving the electronic configuration of scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Alright, so we should start with Sc, which is scandium. Alright, initially it has 21 electrons. Alright, we have seen that now. Now we know that initially electron will be going in 1s2. So 1s2, then 2s2, right? Then 2p6. How many electrons? 6, 2, 2. 10 electrons have been done. Alright, after 2p6, we need to start 3s2. 3s2. After 3s2, we have, 3p6. So 3p6. Let's count how many electrons are these. So 10, 12, 12 and 6, 18. Alright, again 3 electrons are left, right? So after 3p6, we have 4s2. 4s2. And after 4s2, we have 3d10. But we know that here we're gonna have only one electron. Alright, since only one electron was left, so 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 12 plus 6 18, 18 plus 2 20, 21. Alright, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1 is the electronic configuration of scandium. Alright, now we are moving towards the titanium. Alright, so I should write smaller. 1s2, 2s2, then 2p6, 3s2, 3p6 and 3d2. Let's count, are these 22 or not? So 2 plus 2 4, 4 plus 6 10, 10 and 2 12, 12 and 6 18. Wait, I just forgot to write 4s2 after 3p6. So 4s2, then 3d2. Now we can actually count. So 2 plus 2 4, 4 and 6 10, 10 and 2 12, 12 and 6 18, 18 and 2 20, 20 and 2 22. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2 is the electronic configuration of titanium. Alright, now we are moving towards vanadium. So vanadium 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3 is the electronic configuration of vanadium. So now as you can count as well, those electron would be 23, right? 2 plus 2, 4, 6, and you know what, 10, 12, 18, 20, 23. Yes, these are 23. Now here we have one exception in the chromium one, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s, here would be 4s1 and 3d5. Alright, we have just reduced here one electron because we know that here in D we have 5 orbitals. Alright, if I am putting here 4 electrons, right, so this is unstable, and here you know what is S, and here we have S 2 electrons. Alright, so this is said that half filled orbital is more stable than the full filled orbital. Alright, that's why we removed one electron from here and we put this here, because we know that half filled orbital is more stable than the full filled orbital. That's why here we have one exception in the chromium atom. Instead of writing 4s2, we have written 4s1 and 3d5. So electronic configuration of chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. Alright. Then manganese, again we're gonna apply the same method. Actually, I don't have space here. So 1s2, same 2s2, 2p6, 3s2, 3p6, 4s2. I should write here 4s2 and you know what, 3d5. 3d5. This is 3d5. This is the electronic configuration of manganese. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d5. Now we have iron. So electronic configuration of iron: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2. We have, you know what, how much capability here in the d orbital? 10. Alright, so it would be 3d6. Alright, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6 is the electronic configuration of iron. Then we have cobalt. So electronic configuration of cobalt: 1s2, 2s2, 2p6, 3s2, 3p6. Then we have 4s2 and 3d7. This is the electronic configuration of cobalt. Then we have nickel. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d8 is the electronic configuration of nickel. Now we have again one exception in the copper one, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10. Because we should fill the, you know what, the d orbital first. That will be more stable rather than stabling the s orbital. So here we have one exception, right? We have now discussed about two exceptions. What were those? In chromium atom, we initially filled d orbital and we just gave one electron to S. Same as in copper, we just gave one electron to the S and we filled the full orbital of T. Then again here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. This is the electronic configuration of zinc. Alright, so in today's video we have completed discussing about electronic configuration of starting 30 elements of the periodic table. In the next video we're going to discuss about Upper principle, N plus L rule and Hertz rule. This was all for today.